Hi, my name's Taylor Toby. I'm an OpenSciEd teacher and facilitator, and I'm going to be discussing Lesson 7 from the 8.4 unit Earth and Space. What I really like about this unit is the different modalities students use to model the Earth, Sun, Moon system. It's not just a diagram and it's not just a 3D model. They are representing their ideas in both. So, how did we get here? Well, in the previous lesson, students explored lunar phases, and they figured out that the light from the sun shines on only half of the moon. And as the moon moves around the Earth, the amount of that sunlit side that we can see on Earth changes due to the relative position of the moon and the Earth. Looking at this lesson, it is an investigation lesson that is 2 days long. It's about 20 minutes of prep time. It is a hands-on investigation. There is a video, so it will require devices, although you can play the video on your computer and present it to the whole class. So, looking at the first day of this lesson, students figure out that a solar eclipse is caused by the moon blocking sunlight on Earth. And then we wonder, well, does that happen every 21 days, every time a new moon happens? And then on the second day, students figure out that the moon's orbit around Earth is not flat relative to how the Earth is moving around the sun. Sometimes the moon is too high or too low for the shadow to fall on Earth, causing an eclipse. And then that leads us to wonder, well, what does a lunar eclipse look like then? What students will figure out in this lesson is that sometimes the moon lines up between the sun and the Earth, and the moon will cast a shadow that falls on the Earth, and that causes a solar eclipse. Now, in this lesson, we are using the term eclipse, meaning total solar eclipse. Students will not be learning about partial eclipses, nor will they need to understand the terms for the moon shadow, such as umbra or penumbra. The second thing students will figure out is that the moon's orbit is not flat relative to Earth's orbit around the sun. They don't need to know the exact degree of the tilt or draw it or model it accurately. They just need to know conceptually that it's not perfectly flat compared to how the Earth is orbiting the sun. If you do need to shorten this unit and students have no questions about the frequency of solar eclipses, you can shorten or cut the second day. So, looking at some key moments. Part 4 is the modeling. So students will be working with those styrofoam balls to try and see what is causing the solar eclipse they saw in the video. Now, you may have groups that are stumped. They can't quite make the connection for what could be causing the sun to turn black like they saw in the video. So have them think about it more in terms of things they've experienced in their life, such as, has your view of the board ever been blocked, or your view of a movie screen or a play been blocked? Yes, well, what happened? Was it that someone tall got in front of them, a student shifted in their seat, and now their head blocked your view? Help them make the connection back to solar eclipses. They're a person on Earth. The board or the play is like the sun. The moon would be that person getting in their way and blocking their view. And then have them use that styrofoam ball representing the moon to block some of the sunlight and point out it's not the whole Earth that's experiencing it. It's just where that shadow's falling. That area's perspective would be the sun turning dark, not everywhere on Earth. There's also an extension opportunity in here. If you do have groups that catch on to it quickly, there's a link to a simulation that lets them explore partial eclipses and what it means to be in the path of totality, where they'll get to learn about the terms for the moon shadow. The link to that is in the teacher's guide. Where do we go from here? Well, at the end of this lesson, we realize we figure out what happens during a solar eclipse and what exactly that looks like. And that leads us to wonder, is it the same thing for a lunar eclipse? What would that look like? Some material management tips and tricks. For the part 4 modeling, you have the moon on an aluminum wire to represent its orbit. The aluminum wire I find is very malleable and it's easy to distort. So rather than having every lab group work with it, I have one for the discussion afterwards. And then that way we can see changing the plane and lifting it up. It's also very useful when looking at the frequency of solar eclipses later on in the second day, where you're showing that the moon doesn't always position directly between the sun and the earth. Sometimes it's a little higher, a little low, and then it's just a new moon, not an eclipse. Keep in mind, just like with all the other labs, for collecting and distributing materials, there's a lot going on. So I like to assign students to be either the sun, the moon, or the earth, and they're in charge of that piece of the lab materials. Makes it easier for getting everything back and keeping everything from being damaged. When students are working on this lab, blocking light is going to be extremely important. We don't want the light from other lab groups' light bulbs getting in the way and affecting any shadows that are falling on their styrofoam ball of earth. And safety. Those light bulbs can get very hot. They can burn skin, melt erasers, styrofoam balls. So just reminding students to be careful and mindful of where their supplies are while they're working. And I highly recommend, once students are done exploring with a 3D model, unplug the lights, have a discussion as you build towards making your 2D model, your diagram that you're drawing, and then once the light bulbs have had a chance to cool, then have students return the materials for cleaning up. Word wall management. In this lesson, we will learn the word eclipse. So when the location of an object blocks our view of another, and we will be referring back to solar, which we learned in a previous lesson in this unit, meaning sun, and it's the sun that's being blocked. Poster management. We will be referring back to that lesson 6 poster for important parts and interactions to include in our Earth, Sun, Moon system. And then in this lesson, you will be creating the consensus model for how does a solar eclipse happen? And then why don't we see a solar eclipse every new moon? Now, depending on what you do with your class, if you decide to shorten day 2 or get rid of it altogether to shorten this unit because your students don't have questions about the frequency of eclipses, then you won't need the what will move, what will not move poster, or how often we might see a solar eclipse consensus model poster. Those only happen if you do day 2 in its entirety. Thank you so much in joining me with Lesson 7. I hope your students enjoy the 3D and 2D modeling and really getting a chance to explore their sun-moon system in a variety of ways. And I look forward to seeing you in Lesson 8.